Okay, so the next example says that the average room and board expense each year at a four-year college is $10,453, and that's about right. My kid was in college um, up until last year. He quit in May, and that was about what I was paying for his room and board. That's about right, about $5,000 a semester, just for room and board. That was not his tuition. You randomly select nine four-year colleges. What is the probability that the mean room and board is less than 10,750? So, first of all, our sample size is only nine. Nine's not big enough. So we have to keep reading because remember, we won't be able to work this problem unless they tell us that our population is normally distributed. And it keeps saying, if you keep reading, it says, assume that the room and board expenses are normally distributed. So they're talking about for the population, it is normally distributed with a standard deviation. And that's still talking about the population. So this is very important information, okay? This thing over here that we're drawing, this picture, this is for the sample size of 9. So the mean of the population is going to equal the mean of the sample. That's what the central limit theorem tells us. So those two numbers are the same, but we're going to need to calculate the standard deviation for the sample. And we do that by taking 1650, the standard deviation for the population, and dividing it by the square root of the sample size. And when we do that, we get a standard deviation of 550, not 1,650, but 550. So this is a little bit more than I think is one standard deviation. No, it's a little bit less than one standard deviation away. So again, you can't, now that you have the standard deviation, you can calculate a z-score. Remember, the z-score would be calculated by taking 10,750 and subtract away from it the mean 10,453 and dividing it by the sample standard deviation. So you could find a z-score for this x value. Boy, I must be needing to stop making videos right now because everything's freaking out a little bit. I think everybody's tired. You could find a z-score and then use the z-score to go look up on the table and see what the area is. Because when they ask me for the probability, they're asking me for an area. What's the probability that the x value is going to be less than or equal to 10,750? That's what they asked me to find. What is the probability that the mean room and board is less than 10,750? So that's what I'm going to find. And you can find it by taking this, calculating your z value, and then taking that z value and looking it up. Or you can go to StatCrunch. Notice that I put in the mean right here for the room and board. This is the standard deviation of the sample, not the population. The standard deviation of the sample. And then this is my question, and I'm going to compute it, and I'm going to get the probability. So the probability there is 70 point, if you change, well, okay, just let me go write it down. So the probability is 0.7054, and you can change that to a percentage, and they'd probably say it's about a 71% chance. That's probably how how they would answer 71%. Okay, so for this last one right here, some college students use credit cards to pay for school-related expenses. For this population, the amount paid is normally distributed with a mean of $1,650 and a standard deviation. Right here, we're talking about the population. All of this information is about the population. And how do I know they're talking about a population? Well, one reason that I know they're talking about a population is because nowhere did they mention a sample size. So if they don't ever mention a sample size, by default, they're talking about a population. So what is the probability the randomly selected college student uses a credit card to pay for school paid less than 1,000? So they're giving me an X value, and they're saying, what is the chances that, or the probability that the X value is less than $1,400. Now, did they give me any information about a sample? No, they did not. So this question is still about a population. So the mean is $1,615 and the standard deviation is 550. So to find, I would just go to StatCrunch and put those two numbers in, 1650 and 550. So this would be 1650 and 550 is the standard deviation, and they want to know what's the probability that the payment is less than 1,400. So we compute and we get, oh, I put in the wrong number right here. It's 1615. Okay, now compute it and I get 3479. So I'm going to run over here and write that down. So the chances are that it's 0.3479. I'm going to remind you again that you can certainly come over here and use your 1,400 is going to be somewhere on this side, and they did ask for less than. So this is an X value of 1,400, and you can take and find that Z value. You use the formula. Z is X minus mu divided by the standard deviation. So find your Z value, take that Z value right there, look it up on your table, and the area that you find on the table will be this right here. Okay, the area is going to be that right there. So you're going to get the same answer either way you want to do it. Now they go down here and they say, okay, in this problem, you randomly select 25 students who can use credit cards to pay for school. So what have they just done? They've just created for us a sample. The sample is 25. 25 is not big enough. So I must go back and make sure that my population is normally distributed. My population is normally distributed, so it is okay for me to continue to make predictions about the population from the sample. So that means I'm going to need to calculate my S. My X bar, remember, the mean of the sample is going to be the same thing as the mean of the population. The central limit theorem told me that. And now S is going to be calculated by taking 550 and dividing it by the square root of the sample size. So that comes out to be 110. So that's the new standard deviation for the sample. And they want to know what's the probability that this will be less than 1,400. Okay, so it's not the same problem because it may look the same to begin with, but remember, these are the two values that we put in StatCrunch, and now we're going to put in these two values, and so we will get a different answer. So we're going to come over here now and go to StatCrunch, and we're going to change, this is the same, and this is going to change now to 110. And now we're going to compute it, and it's a much, much lower probability. So this is 0.0253, and that can be rewritten as 2.53%. This one can be written as 34.79%, which would probably round up to 35%. And it says, compare the probabilities in these two. So basically, what it's saying is that from the sample, there's about a 3% chance that the student will pay less than $1,400. And from the population, there's about a 35% chance. So the more people you have involved, the higher the chance of them paying less than $1,400. The smaller the sample, the percentages decreased quite a bit. And you will need to know for future questions, they may ask you what's unusual, and I think they do that in a couple of your problems. They ask you if the outcome is unusual, and anything or any percentage right here that's less than 5% is unusual. So this outcome is not at all unusual. This outcome is unusual. Why? Because it's less than 5%. So that should conclude this super, super, super long lesson.